So that's not quite data science, that's a little bit big data. Let me talk a little bit more about data science, and this is something that I am politely adapting from Michael Rappa. You guys know who Michael Rappa is? Some yes, some no. How many know what the Institute for Advanced Analytics is? IAA? Everybody's nodding, because everybody knows about the master's program in analytics, because lots of our undergraduates want to apply to it, and all of us, Okay. So Michael Rappa is the head of IAA. He's the one who had the idea and got it going. And so these I'm stealing from one of his interviews. I think this one was in Forbes. But again, he's talking about, when you're thinking about, he says he trains data scientists at IAA. I mean, that's his big thing. And so what I thought was interesting is one of the things that he articulates is what are the 5 skill areas that he thinks data scientists need. And IAA is one of the most recognized programs in the US, maybe around the world, for training data scientists. So let's at least think about the way that they think about training people. So the first skill set is technical. Anybody got ideas? What's the technical skill set? Statistics is one, learning, machine learning, pardon? Writing code. I'm going to argue that it depends on your perspective. Because for many statisticians, they would tend to put the coding under tools, whereas the computer scientist would tend to put coding as the technical skill and statistics as the tool. Statisticians will tend to, but it's okay, you're right, that's one of the things. So again, these are not clean, but these are things to think about. So the technical skills, you guys are undergraduate, graduate students, this is what you're doing. This is actually what traditional departments are pretty good at. We're going to send you through a series of classes, and we're going to get you a bunch of technical skills. We're going to teach you how to do regression. And you're going to form a club to learn how to do the stuff we aren't teaching you how to do that you think you need to learn to do, right? Okay.
More or less.
Yeah, more or less. It's fair. I get it. We recognize the gap. We haven't figured out what to do about it, but we recognize it. Okay. So technical skills. School is really good. Departments are really good at giving you technical skills. Unfortunately, if you want to be a data scientist, you got these 4 other things. So we got to talk about those. Skill number 2 is communication. And it's you were a really good setup man for this one, which is you have to be able to talk about statistics to non-statisticians. Because data science is, and you got this, I liked what you said, it's about answering questions. But again, it's not about X1 to XNIID. You don't get to lead with that. I'll say those of you who have taken to the consulting class, you also don't get to lead with just tell me what your data is. Okay? That's the one that always makes me crazy. It's like, you can't start there either. So how do you talk about it? How do you understand what questions are? How do you talk about what you're doing in English? How do you figure out how to communicate this complicated statistics ideas? Okay, so that's the communication part. Something like this where you talk about the stuff you're doing. You take an idea you don't know about and you figure out how to talk about it to another room full of people who don't necessarily know it. There's a lot of shared knowledge here. But communication is something you learn to do, and it can take some time. I've been working for about a year with some folks over in material science, and after a year of hard work, we can almost always understand what the other one is talking about. And where we've gotten is we actually are recognizing very quickly when we are using the same word to mean 2 different things. But that takes time and a lot of effort. Okay, the next one is collaboration. And this gets back to what I just said. If you go back to the previous slide, some of you all may be virtuosos. Our seminar speaker this morning, for those of you who heard him, there are a few people who actually are really, really good at all 4 things. And then there's the rest of us. I can situate my work in 2 of these areas, but there are a lot of situations that I'm in that I need to translate my work to pick up the 4 V's, and collaboration is key. For those of you who are going out in the world to work as applied statisticians versus wanting to sit in your office and prove theorems, and they're both valid ways to work, as a statistician, especially moving forward, this collaboration is going to be really key because typically it won't be your question that you're answering. It's going to be the material science guy who says, okay, look, I've got these 3 different instruments and they all tell me something different about the material, and I don't know how to put that together and understand how well I know the structure. Okay. I actually know how to help him with that problem, but it's not fundamentally my problem. So we go back and forth with the communication and collaboration. So you've got a venue for communication. Then the question is, how do you guys start to pick up collaboration skills? And what does that mean? And how do you start to do that? That's really key. I mean, we give you a tiny little taste in consulting class, you know? And some of you, depending on where your research work goes, you know, you'll be working on a problem where you have to talk to somebody, you know. But that's one of the key skills, and it's a key skill because, again, I think in data science, we get the interdisciplinary, multidisciplinary, transdisciplinary, pick your favorite, you know, prefix on disciplinary, but it's getting to be the case that you have to put together sets of ideas and knowledge that are broader than what you have, and so that collaboration's a big piece. Okay, so next thing is tools, to get back to what you said. When you've got your statistician hat on, this is typically viz, code, you know, all of the data wrangling, data curation, Hadoop, you know, all this stuff, you know, how do I program a GPU? You've got to, if you want to play in data science, you have to be able to deal with the computer. You have to be able to not necessarily deal with things at scale, but that doesn't hurt. But you have to have a set of tools. You have to be able to do something more than run proc freak. You know, I mean, you should all be good SAS programmers, and not because, but I actually think because SAS is an incredibly useful language for data wrangling. SAS is very, very good. Data steps, there's a reason why the first course you take as an undergrad here is you want to slit your throat while you're going through it, but it's a data step course. And well, it's boring, but it's useful because it teaches you the basics of data wrangling, all the stuff you've got to know. You know, is it a character or is it a number? You know, I mean, can you dedupe records? Can you merge things? What do you do if you don't have a clean merge variable? All of that stuff that you have to do to build a reasonable data set in SAS using a data step, it's the same questions. And so instead now of having to do it on 1,000 records, you have to do it on a terabyte of data by tomorrow at noon. Okay? But it's the same questions. So does that make some sense? So there's tools. And so we teach you a subset of tools. Unfortunately, the tools are growing faster than our curriculum is. So another thing you guys have to start to think about, which is we probably didn't teach you GitHub in one of your classes, or maybe we did. You know? Pardon? Yeah. You know, so you know a little bit of SAS, you know a little bit of R, do you know a little bit of Python, do you know you're going to teach some data scraping? You know, do you know how to script? You know how to data scrape? You know, there are a lot of techniques and tools depending on what you want to do. And so that's sort of the tool bucket. And then there's the whole subject matter expertise thing, and this is where data science gets interesting. So the idea here is that you're asking questions about something, you know, about materials, about, you know, genomes, about whatever you're asking it about. You know, a key piece of data science is it's not just about running the regression, it's about answering the question. And so then the question is, so it isn't necessarily the case that you can just be the expert in the technical stuff. That sort of used to be the case. But now, if you're going to talk about doing data science, you have to make an argument that you are somewhat knowledgeable about something else too. You know, about, I don't know, air defense artillery. That was the first one I ever had to get knowledgeable about. You know, you guys don't even know what that is. I didn't either. You know, I got a PhD and got a job and went to work for the Army, and suddenly I was evaluating air defense artillery. I didn't know what it was. I mean, I didn't know how to read the insignia on the uniforms. I mean, you know, and they said, oh yeah, now you're going to be, it's like, throw me a clue, you know, I mean, and so I think a lot of you who want to work in this space, you're going to end up, again, and this is not different for statisticians, we've done this for a long time, but you end up developing deep understanding of the particular areas that you're working in. You know, and for some of you guys, that's going to be marketing, and for some of you guys, that's going to be air defense, and for some of you guys, that's going to be material science, and for some of you, who knows what it's going to be. But again, there's this idea in data science of that deep engagement with particular areas. Okay? So I don't know if this helps, but you know, again, I have this vision. You're going to go on a job interview, and the poor HR person is going to say, so, talk to me, you know, why should we hire you to be a data science intern? And the answer cannot be because I'm getting a PhD in statistics. Because you missed 4 of the bullets. I mean, yeah, that checks bullet 1. But why should they, you have to be able to think about how do you give examples of what you know or what you've done in each of those areas. Why should we hire you? Because I've been in school to get strong technical skills. I'm part of the statistical learning group, and I've had the opportunity to develop my communication skills doing A, B, and C. In my consulting class, I was able to, really work on these kind of collaborative projects where I've had the opportunity to do this. Not only have I learned SAS and R, but I've had the opportunity to do some data scraping in support of this RA project that I've done. And the reason that I want the job is because your company actually is working on an application I'm interested in, and it's going to give me the opportunity to develop some deep subject matter expertise and figure out how to apply all of these things. Okay, I've done this before, but anyway. So yeah, I've been on the other side of the table, and you kind of want to feed it to them. It's like, oh, please say this, please, because then I can hire you. Anyway, but again, a lot of you, sort of the statistics learning piece, a lot of you are in here because you've got interest, you've got interest sort of in the technical and the tools, and some interest in the communication because of the way you're running the club. And so these are good things to think about if you might want to work sort of in this data science space. And if you want to cross that with the big data piece, then you have to figure out how to talk about where are your interests in this space? What have you done to think about working with data at? So the volume piece, when people talk about working with data at scale, they tend to be thinking about volume, right? Streaming, you hear about streaming, that tends to be velocity and streaming are the 2 words that get put together. Variety, only statisticians mostly ever talk about that, but that one we kind of understand. And then veracity is typically uncertainty, although you're going to hear some. How many of you all have heard Colbert's, the truthiness idea? And so actually, veracity is either uncertainty or truthiness. To the extent that you can think of that as a technical term, but again, you'd be surprised. So, okay, I'll stop talking and let you guys ask some questions. Oh, I have one. So back to the idea, sorry. Can you tell? I'm kind of interested in this. So I brought one up earlier. What's an analytic? Yeah. Okay, so we got 1 vote for analytic equals data mining. Okay, yeah.
At least in terms of, I would put that kind of along analyst, which at least in job posts and stuff, that mostly is everything in the gathering and cleaning / wrangling, and then it stops, and you pass it on to someone else.
Okay.
Now that's more analyst, I guess, than analyst. I guess when I think of someone that does analytics, I think of someone just not as good at marketing themselves as a data scientist. Because you get a higher salary bump than a data scientist would get.
Okay. So we've got the set O stuff that happens after the data curation, data wrangling, data munging kind of bit. Okay. Any others? I'll tell you what I think it is. And of course, I run a lab called Analytic. So I actually, analytic to some extent is, for me, it is very tied to the idea of analysis. But when I start, again, with the statistician bias, I tend to think of something you calculate from data, almost our classic definition of statistic. So it's something that you compute from data. And data mining, that's some of how they make, data mining was the sexy term, now it's analytic. But we do analytics too. We just have a different set of analytics that we teach you in classes. We don't call them analytics, we call them models. Okay? And then you say model to a mathematician and they're, So analytic is not an incredibly well-defined term, but you guys do analytics. I mean, you guys, you take data and you make computations to address questions. You have to be a little careful though, because to tie back to the idea over here, sometimes analytics are analysis processes. So the intelligence analysts who work for the government over at LAS, they don't compute anything. But they say that they do analytics because they are thinking about how do I use information to answer a question, and that process for them is an analytic. So there's the how do I get from data to answering question, and the set of analytics we tend to all be interested in are the very quantitative ones, and the machine learning ones, and the and the regression ones, and the what have you. But it's a pretty broad term. And anyway, okay. Sorry, I said you were going to get to ask questions, but I like the analytic one. Okay, how about you guys? Yeah.
Can we go back to the slide? So, I mean, we see obviously a lot of the veracity. I think we get, relatively varying levels of exposure to the variety. But I guess my question is, I understand the velocity, but where would you say, or how would you best learn to deal with the velocity of streaming data? Because, volume, people are like, oh, just do distributed computing, and we learn statistic methods to deal with veracity. But the velocity is the one that I just am completely at a loss as to, like, how...
Yeah, and you can see how well we figured that out by the course that we teach you in how to deal with streaming data, right? That one's not completely trivial. You can imagine lots of, you can imagine, I was going to say, if you guys wanted to do a project, so, try to find, as a group, plug yourself into a Twitter feed, into just watching Twitter run by, and see if you can find emerging topics. How do you do that as it flows by? I mean, you can imagine lots of open data, that, how do you find it? I don't know. I mean, and that's the problem. That's some of why it isn't. I mean, I can imagine developing a course in streaming data analytics, where we could talk about specific things you might want to do with streaming data and teach you algorithms. It's almost an algorithm course. And part of the problem I think we have is it's still at an area where, for me, I tend to think in one-offs. Suppose you want to calculate the median from a stream of data. I can teach you how people have thought about doing that. But I don't know. And it may be that the computer scientists know how to do this. There's a great book on, streaming analytics, and statisticians don't know. I don't know a good answer to that. Let me know when you figure it out. So when you guys who are graduating, if any of you guys go out and figure out a good way to teach velocity, drop me a note because it's hard. And I mean, I think it's one of our challenges as a department, and we would like you guys to, if you want to go be data scientists, or if you guys want to go play in big data space, we're trying to figure out how to give you the option for us to support your getting that training. And there are pieces of it we know we aren't doing very well. It doesn't mean we don't want to, it means we aren't doing it very well, and we're trying to figure out how to do that. Anyway, but velocity is a big gap. I mean, you do a little bit of volume in some of the advanced computation classes. I mean, and we do some in 3 of the spaces. I'm arguing we probably don't do very much right there, right now. So, which is true. Other question? Yeah. 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 Yeah, I mean, I think, I'm going to say, buy me a cup of coffee sometime. So, over time, I think it morphs. I mean, I think through your career, there's a generational difference, so my father, World War II vet, worked for the same company his whole career, right? And so he became subject matter expert in one thing. He sold automation to banks. ATMs, the things tellers type on, that kind of stuff. He knew everything there was to know about that. Okay. Then you get to my generation of so I'm Gen X. Then you get to the generations past me, and people change jobs every X number of years. 3 years. I think none of you can probably imagine having the same. You can imagine having the same job for your whole career, and you have no idea how to actually make that happen. And so yeah, I mean, you have to do it, and you have to. But one of the challenges if you want to work in data science is you have to figure out how to get expert fast. And it's a process. I mean, there are skills that you learn that help you communicate. There's skills that you learn to help you collaborate. There are tools that you learn to help you work in the space. And there are skills, remember, this is on a skills slide. There are skills that you can learn to help you become more expert more quickly. And so yeah, I mean, I think that you do actually, there is, I still do a little bit of air defense artillery, but, I came out, I had done, my dissertation was in looking at variation in shapes in brain images. And I needed a job in El Paso, so I started evaluating Army systems. You are going to change your statisticians. Some of you will be lucky and you'll get to work on biomed your entire career. And some of you will be lucky and you'll get to change every 3 years the cool and interesting science problem that you get to work on, And if that's how you like to work, I think you do figure out how to do that. So anyway, this was not meant to be the Dr. Wilson show. So, yeah.
Let's go back one step to the big K. I guess even this slide where that's my boss at GSK, who runs the advanced analytics group, pretty much just a group of individuals that make up all these skill sets that you're talking about.
Mm-hmm.
None of us know all of them, but it's a team of people that together
Right.
are able to develop it. And he shared with me there's a picture, it was actually put out by SAS,
Okay.
of what is a data scientist. And it had the 4 areas, one being like statistical methods, one being visualization,
Okay.
communication. There was another one with like relational algebra type stuff for computer scientists and things. There's a lot of words I didn't understand.
Okay.
But he showed it to me and said, he's like, literally no one coming out of school ever has all these skills.
Right.
And then, so he always talked about is have your area or a couple that you feel very comfortable with and being able to demonstrate that you can learn the others. And so you gave a really nice rundown of those 5 skills. But do you have any rundown of kind of this idea? So you were talking about we're coming out, we have a little experience in volume, more so variety and veracity. How do you sell yourself in the idea of I can learn these other things? I might not know much about velocity or have experience in it. A little more of that, the interview.
I'm smiling at man who has a job. So how did you position yourself as someone with that capacity?
It's more so the idea of demonstrating, like, I wrote down, like, through my journey in, like, learning how to code. I first got formal training in Java. Everything else I've just taught myself.
Mm-hmm.
And so this idea of I'm able to, you don't back down from a challenge. And also talk about, in my own PhD work, getting a PhD, your advisor helps you a little, but a lot of it you have to do it on your own.
Right.
And you're not, and it's, sometimes things are going to be intimidating. You open up with something about, I don't know, L2 entropy spaces, and I'm like, I have no idea what this is.
Yeah.
But you just have to buckle down and do it. So
Right.
that, but I guess you have a really nice, concise one.
Yeah.
I tend to ramble a little when I talk, so that's a really nice, concise one.
Yeah, I think to be honest, the easiest way to demonstrate that you have the capacity to pick up new skills is to give examples where you have picked up new skills, which means that you have to construct. So if you are getting a PhD or a master's degree, you have something built in, which is you're going to write a dissertation. So you're going to have 3 built-in projects along the way that you can talk about how you learned new things. You're also going to have your consulting project. You will have a summer internship. You will have a research experience for undergraduates. You will have the job that you got. The only way that I've ever heard a convincing version of that is to pick an example. But that's actually, again, it's becoming a more and more important question, again, when you're positioning yourself. So, if you're going to work as a data scientist, clearly this is something where you're going to have to both pick up new skills and work collaboratively. Do you have any evidence that you can do that? You need to be able to answer that question, and if you're looking at your path through school and life so far, and you don't have good evidence, you haven't had the interesting job, you haven't done the research experience, you need to start knocking on some doors and sending out some resumes. Because no promises that school doesn't get you all 4 of these and all 5 of these. We get you some, and we have good contacts and we help you get a job, but that summer job or that research experience. But to the extent that you guys are interested in this, this is why, these are not the only maps. These are the ones that make some sense to me. And as you're talking about, there are other, go Google around. You're going to find one that makes sense to you. If this is where you want to work, figure out how do I, this is part of what this club is. There's a part of this space that you guys said, I'm not getting this and I want to learn more here. Yeah, so think about how you do that. But, the examples are good ways to demonstrate that when somebody asks the question. So anyway, I know we're running late. So anyway.
Well, let's thank Dr. Wilson.
Yeah.